We covered the general forensic process in Unit 1. Now we will study technologies used in computer forensics for Linux Unix operating system. Linux Unix forensics follows the general forensic process of collecting, preserving, analyzing, and reporting evidence. In the next few lectures, we will focus on forensic tools and the technologies used in investigating Linux Unix systems. Before we start a forensic investigation, we should have prepared for a couple of things. First is a set of forensic tools, including a bootable live CD. The reason is simple. You should never trust any tools from the suspect machine, since it has potentially compromised. If you have to reboot the suspect machine, you will boot the system using a forensic bootable CD. Because booting a system using its original operating system will modify data and metadata on system drives, for example, files access times. When booting using a forensic bootable CD in a forensic mode, the internal suspect hard drive is not touched. Second is a powerful machine. Sometimes we call it forensic machine or evidence server. This system has forensic tools installed, and its drives are wiped clean for storing acquired evidence. I have to point out that not every tool can be called a forensic tool. We learned that the Unix command CP is a great sysadmin tool, but it is not a forensic tool, because copying a file using CP will modify the original file's access time. This action alters evidence, and in some cases, access time is potentially of crucial evidence for investigation. In general, forensic tools have these properties. First, they must conduct a forensic sound operation. That is, they do not modify evidence. Next, the system analysis tools usually can work with both acquired images and live systems by taking a partition or disk image as input. These tools are capable of processing data structure, bypassing kernel support, because we are expecting them to show us deleted content and other data that is typically hidden. Now let's move on to the acquisition process for both volatile and non-volatile data. In this video, we will study technologies for volatile data acquisition. Volatile evidence is evidence that can easily be changed. And some evidences, for example RAM, is more volatile than others. If the suspect machine is up and connected, volatile evidence such as running processes, memory dump, and network connections, logged in users are still available to be collected. Every memory dump will be different, since memory is constantly changing. That's why we should first acquire the data that is most volatile. A possible order of collection from most volatile to least volatile until non-volatile is memory, swap space or page file, network status, connections, processes running, open files, drives, and removable media. Since you are directly collecting volatile evidence from a suspect machine, you are inevitably changing data. To ensure a minimal impact to the original data, you should always try to use small footprint tools. And you should always document everything you have done. Now let me show you some Linux Unix commands that can be used to collect valuable system information. For example, Linux Unix command lsof will list all open files that belong to any active processes. The common syntax is list open file, followed by optional options or file names PID. If you only run lsof without any options, it will list all open files. The tool is actually quite powerful in Linux Unix world because everything is a file in Linux Unix. RAM is a file named /dev/mem. A directory is a file, and even a keyboard maps to a file. So a file can be a regular file, a directory, a block special file, like a hard drive, a character device file, a library, or a stream network file connected to TCP ports. Here are some examples of list open file and what they show. LSOF-I IP address will list internet connections belonging to the given IP address. Now the next list open file command will list all open IPv4 network files. And certainly it can list all open files on a device, and also it can find a process that has the given file open. Most interestingly, you can find LSOF to find malicious processes that use hidden disk spaces. Here is the scenario. If you create a process that opens a file, while the process is still running, you can delete the file. Since the file is still open in memory, you can continue to write to the file, but it is invisible to the ls command since you have deleted the file. List open file plus L1 shows you all open files that has a link count less than 1. I assume you have the prior knowledge of basic Linux Unix file system to understand what is a link count. Please review it by yourself if you don't know. A link count less than 1 means the file is requested to be deleted. Once you find the open file, you can run list open file given the file you found to find which process that has this file open. Here are the other commands that will provide you useful information about the system live information. For example, date shows current system date time. Uptime shows when was the system rebooted. Uname will display system information. Ifconfig will display network interface, whether you can find that it's running in a promiscuous mode or not. PS or top show you all the processes, and netstat and list open file will show you network connections. Who or W or users will show you logged on users. When we run these commands, where should we save the result or output? As I mentioned in Unit 1, we have to redirect the result outside of the suspect machine to avoid modifying the original evidence. Commonly, you probably will use redirect option greater than or greater than. Here, let me introduce a well-known computer networking utility called Netcat to redirect output to a connected machine. Netcat, in some cases it's NC, is designed to read from and write to network connections using TCP or UDP. It is a powerful tool with many features, and people call it the Swiss Army knife for TCP IP. How does this tool play a role in the computer forensics field? Forensic examiners use Netcat to transfer the retrieved data to a forensic workstation over the network. Here's how it works. First, set up Netcat listener on the forensic workstation. Any received data will be stored in a file. In this case, we call it meaningful name. And we are listening on port 2222. So netcat-l means listen, -p is port, and then the file will be directed to meaningful name. If we want to send information of who is currently logged in from the suspect machine to the forensic workstation, let's say the forensic workstation IP address is 192.168.0.2, and we will run who at the suspect machine and pipe to Netcat, the listener machine's IP address, and then the port what is listening, 2222. You will notice besides Netcat, there is a similar tool called CryptCat. CryptCat's functionalities are similar to Netcat, except that CryptCat encrypts the data between the senders and then the receiver.